It's impossible to find the position and the speed of the electron at the same time, and this is the defect of Bohr's theory. So Heisenberg destroyed the principle of the orbit. That means the electron is not found on orbit. So the question now, what is the real place of the electron? Or where can we find electron? So the modern quantum mechanical model, which is the real model of the atom, describes the motion of the electron around the nucleus. According to Heisenberg, the position and the speed could not be known at the same time. So I will consider an orthonormal system X, Y, Z, where the center of the system is the center of the nucleus. And I will suppose that the electron is found at the point M of coordinates X, Y, Z. This electron at this position M has a known distance from the nucleus, so has a known attraction by the nucleus. So it has a speed v. So at point M, X, Y, Z, I will suppose that the speed of the electron is Vm. According to de Broglie, any particle in motion of mass m and the speed v, its motion is a wave, and lambda of the wave is equal h over mv. So I can calculate the lambda of the motion of the electron at position m, where lambda m is equal h over m times vm. Suppose the electron will pass to another point n of different coordinates x prime, y prime, z prime. So this electron is not attracted at position n by the same way as the position m. So the electron has another speed I called Vn, and the motion of the electron in this case is a wave, and lambda of the wave at this point is equal h over m times Vn. So what is the motion of the electron in the atom? The electron in the atom can take any position. I don't know the real position of this electron. But at a certain position, I can determine the speed v. Okay? When I determine the speed v, I consider that the electron is at mxyz. But perhaps the electron is not at this position. I suppose that the electron is at m. So I calculated Vm. When I calculated Vm, I calculate lambda m. If the electron passed to another point, so another point n, the speed is different, the lambda is different. So I will say that the motion of the electron in the atom around the nucleus is a wave. With de Broglie, we say that the motion is on orbit. With the Bohr, we say that the motion is in orbit. Now we say that the electron is moving around the nucleus, and we describe its motion as a wave. But lambda of this wave is different. It depends on the electron in position m, n, p, or other point. So the motion of the electron around a nucleus is a wave. Lambda of the wave is different. So the motion of the electron around the nucleus can describe by a wave function we called psi. The wave function we called psi that depends on the position of the electron of coordinates x, y, z. So the electron is not found, as we described in the college, around the nucleus in electronic cloud. The electron is not found on orbit as described by Bohr. The electron can take any position around the nucleus. And the motion of this electron can be described as a wave function if you determine its position. That means you know x, y, and z. You put the value of x, y, z in the expression of psi, and you calculate the wave at this point. So the Bohr model uses orbits, the circular position, and this is the defect of Bohr. The quantum mechanical model states that we don't have a definite place of the electron. The electron can take any position around the nucleus. So what we calculated, if you give me a point around the nucleus, I can calculate the probability to find electron at this position. Suppose you gave me the position M and you told me calculate the probability of the electron to find electron at M. I will calculate, I will do mathematical calculation, and I will calculate psi at this point. Then psi square is the probability of presence. So I will find probability equal to 0, or equal to 10, or equal to 20, or equal to 80, or equal maximum to 90. What is the meaning of probability equals 0? That means the position you gave me at this position, we don't have electron. We don't have presence of the electron. I ask you, give me another point. You gave me, for example, the position N. I calculate psi at this position. I calculate psi at this position, psi x, y, z. So psi square is the probability. I will find, for example, probability equal 15%. What is the meaning? Meaning the electron, the probability to find electron at this point you determine is 50%. 40, 50, 60. Why the probability is 90% and not 100%? If I say that the probability to find electron is 100%, I'm sure that the electron at this time is at this position. But since the speed of the electron is very high, so it's impossible to find an electron at a known position. So the maximum probability is 90%. So now Schrödinger in 1926 find a differential mathematical equation that define the location of the electron in space for atoms having one or more electron. And this relation is delta square psi delta x2 plus delta square psi delta y2 plus delta square psi delta z2 plus 8 pi 2m divided by h square e minus b psi equals 0. This formula is not requested, and the proof of this formula is also not requested. You have to know what is the meaning of psi. So as a conclusion, I don't know the place of the electron around the nucleus. I ask you to give me a point. You determine, for example, the point M. When you determine the point M, that means you gave me the coordinates x, y, and z. So I put x, y, z. In the wave function psi, I will find a value of psi at this point. Then I will consider the square of psi. Psi square, this is the probability to find electron at this point. And the probability may be between 0 and 90%. In this relation of Schrödinger, the mass is M is the mass of the electron, E is the total energy of the electron at the position you gave me or at the given position, and V its potential energy. Psi, you give me X, Y, Z. I solve this equation, so I calculate psi at this position X, Y, Z. Then psi square is the most important term. Psi square is the probability of presence of this electron at this position.